Hello, everyone. Welcome, everyone, to our talk. Let's start. It's really amazing to see so many people coming to our talk today. Looks like this topic of renaming metrics is really, important. So it's very relevant, and hopefully that's why you are here. We have really exciting content for you, so let's go. Let's not waste our time. So why we are here today? Imagine the following scenario. You have a counter metric that is exposed and scraped, from some example application exporter or production application. It's very important, right? This metric is very important. You use it on important alert, dashboard. Maybe it's using, you are using it for auto scaling and, and SLO tools and so on. And if this query stops working, you have essentially a production incident. For example, if you use it in auto-scaling, if this query is broken, then you cannot scale your workloads for customers. You cannot start things. So it's a super serious thing. Imagine that. And it happens, right? Suddenly, after the underlying server application that was giving us those metrics, this application restarts. And suddenly, after that, we don't have the query working again. So what happened? After some stressful debugging, you kind of take a look and you realize that the application with this key metric was upgraded to a new version. And this new version actually renamed a metric and made a small naming changes to the metric. So what's worse, it's not only a metric name, but it's actually a couple of labels, right? So it changed, integer to my number and category to class, and then label value change through, to get uppercase, just because maybe, it was clearer and easier to read. In our experience, it's actually a very, very common scenario. And it causes a lot of friction for both consumers, of course, users who have their queries broken suddenly out of nowhere, but also for producers, for maintainers like us, who are afraid to rename metrics, literally, because it can cause possibly those issues, right? And the honest truth about this talk is that when we proposed it in October, we maybe had a small vision how to fix it, how to improve it, but we also knew that the current solutions to solve this are kind of weak or not existing. So we were kind of like, okay, this talk will be a little bit of moaning and sadness. But actually, it surprised even us that in the CNCF ecosystem, both OpenTelemetry and Prometheus communities worked on there are existing core fundamental pieces that combined together allow something truly, truly magical, right? So imagine there is a way to pin your queried metrics to a certain version, like you do with your code dependencies, right? Like you do with your Git branch, like you do with your HTTP requests. So today's talk is exactly about that. We want to show you a prototype of a solution to this problem in Prometheus ecosystem, using several pieces from OpenTelemetry project as well, and give you a chance to give us a feedback as a Prometheus maintainers, developers, if this is something you would like to see in a next version, if it's something you would like to do with your metrics. So this is the plan for the next 20 minutes. And we do this in 3 sections. First, we'll talk about why renames even are problematic, why we have to do them, how to handle the renames in the current state of the things, and what could be a possible future, short-term future actually in Prometheus. But before that, a short introduction. I'm here with Arianna.
Hello, everybody. My name is Arianna, and I am a Prometheus maintainer. I'm a software engineer at SafeSpring. Well, starting Monday, wish me luck. And I have a background in the music business. Yeah, so my hobbies, well, not hobbies, like real passions are synthesizers and history of art, apart from coding, of course. What about you, Bartek?
Sure. My name is Bartłomiej Płotka, but you can call me Bartek. I work at Google. I'm a tech lead for a Google-managed Prometheus of Service. I maintain Prometheus project and several, ecosystem projects like Client Golang, for example. I love generally Go, and I maintain other projects. I co-author Thanos project as well. I'm active in the CNCF, and I also wrote a book called Efficient Go, and I just love solutions that are, efficient and pragmatic. And recently, I also started motorcycling, so some kind of adventures. I really recommend those. OK, so let's go.
Absolutely. So let's start by addressing our first question, which is why it is hard to rename metrics. But if you think of it, it's not like renaming metrics per se that it's hard, right? It's like avoiding the bad consequences of the renaming. But before we delve further into the matter, let's establish what we mean by renaming metrics. What does mean? So, changing a metric name quite obviously falls into this category. Well, but also changing the label names or label values with some semantic equivalent, of course, is also part of a metric renaming. But then there's also the particular case where you might want to change the unit in the metric name, and then you would have to change, of course, also the label value, which is even more difficult because then you also have to change the sample value because the unit has changed. So now that we know what we mean by metric renames, let's see why this is not trivial. So when you rename a metric, this breaks everything relying on that original metric, like user queries, like dashboards, like automation, like alerts, recordings, etc. Lots of things. So renaming metrics is also not trivial because whenever you have like a metrics overall, it's difficult to communicate this to the end user in an effective and timely manner. And no matter like how long the grace period you give your end users, no matter how big that is, how long that is, then in any case, some is going to be taken by surprise, and you don't know how the consequences are going to be and the extent of those consequences. That's unpredictable very often. And things are even more difficult when your end users have distributed systems, because then you have to sync many components, like, for example, the client part, the collection storage part, the consumptions part, like the dashboards and everything, and that needs fixing in multiple places, in a way that everything is harmonious and synchronized, and that's not trivial at all. So, after having told you about all of these problems, you might wonder, but we really have to do this, like really, really? Often, yes, you really have, because sometimes it's really, more than sometimes, it's really inevitable. Like, for example, when you have to apply new recommendations and adapting to naming conventions like base units and suffixes. You see, we have a lot, nice cornucopia format. Or when you have to switch from different kind of metric ecosystems, like from Prometheus to OpenTelemetry, or the other way around. And you see that the syntax of the naming of the metric is incompatible. I mean, you have to deal with those dots somehow. And sometimes you might happen to name your metric in a way that you think it makes sense, but then maybe you use, like in this example, a suffix that is actually like kind of reserved, like in OpenMetrics. Let's pretend, well, not pretend, this is actually a Java application. And if this is instrumented with Prometheus client Java, for example, you have like this metric ending with _created, client Java is going to trim that, and if you have another metric that was called exactly the same, but without that suffix, of course there is a collision. So you have to find some sort of a schematization. In this case, it's like adding another underscore at the end of the underscore created. In any case, you have to do that. And then sometimes, I mean, you respect all the conventions, all the formal things, all the suffixes, and all the rules, and etc. But then you really realize, I should have named this metric better. This does not convey the meaning that it has. I mean, this is right, like, no. But then, this is something that we experienced like last year when we were doing some housekeeping in client Golang, Prometheus client Golang. We were like doing some housekeeping in the Go runtime metrics that the client supports. And we realized that there were really metrics that, this name doesn't really make exactly sense. It could be named really better, like this one. You read Go GC duration seconds, GC stands for garbage collection, and you think, what does this measure? The cycle, the duration of the garbage collection cycle, right? No, it does not do that. It's actually the duration of the stop the word phase of the garbage collection cycle. But that's misleading, right? So we really wanted to change that, but we got scared. We got scared because we realized like the magnitude of the repercussions because of all the users that client Golang has, and since it was like, okay, it's compliant for all the rest of, no, let's not do that. But this gives me the access to lead you straight into the next section, which is what strategies can we use this day, right now, to mitigate the unwanted effects of rename, so migration strategies, basically. So we came up with 5 categories under which the main currently available implementation strategies fall into conceptually. So this is not like an official taxonomy by all means, it's just something that we came up with and made sense, like a way of grouping these different strategies. So let's go through them and their pros and cons. As anticipated, the first is the no change strategy. So when you have like a stable project that is really popular, like Client Golang, you might not want to change the metrics because changing would be way worse than actually not changing. We, for example, in Client Golang have like on top of dynamic Go runtime metrics, which can change every time there is a new Go version. We have like a sort of protection layer, so that with stability tests, so that the changes that every time can be made to the Go runtime metrics on the Go team side do not propagate automatically into our client. Also, like OpenTelemetry has the same thing happening with semantic convention. They have stability tests and frameworks to make sure that you deprecate an old metric instead of renaming it. And also Kubernetes, the Kubernetes framework for SIG instrumentation also has this kind of tests. But when you do decide to go for change, what are the choices available? Well, the first one is, the most intuitive probably, documented change. So one notable example, again, is the Kubernetes SIG instrumentation framework that generates documents related to metric changes and their stability automatically. OpenTelemetry semantic convention, same, like analogous thing. You also can generate documentation from definition and their stability and deprecation level. So what is the pro here? Of course, it's like a centralized source of truth. And it's also, at the same time, a way to communicate to your users, like, at the same time. But that doesn't do the practical work. I mean, you have that, but then your metrics still stay unchanged. So you have to do the work yourself somehow. So what do you have? If you don't want to choose that, then maybe you could rely on translating all the versions of the same metric to a certain known version, like you would do, for example, in Prometheus, with relabeling via this parameter called metric relabel config. And I think also Datadog does something similar with vector. But in any case, the advantage here is that you have the same version in storage, so that's good. But then what are the drawbacks? That this is like a kind of let's say, superficial kind of thing, because, OK, it is like affecting the labels and the metadata, but it does not touch the samples. And also, like, if you were to switch to query time versus write time, that would not be easy at all. So what's next? You could also go for writing all known versions of the same matrix, an example of which in Prometheus is doing this with recording rule. The pro is that, OK, you can still use the old and the new names. And this allows you to, for a kind of a gradual transition between the two. But the problem is that during this migration, that, by the way, you don't really know like how long it's going to last, you have to account for double the storage, because you will have to make space for both things at the same time for as long as the migration lasts. And of course, that gets even worse when there is more than one update for a single metric. And this is really super manual as a burden, and it's very tricky in practice. So the last current strategy that we identified, and we called it like version read, basically, or we categorized it under version read, is the practice for which you pin a metric to a certain version when you query it. So in Prometheus, this would correspond, for example, to making queries using the OR operator, as illustrated. This is not super recommended, of course. Or you could even, like in a very naive way, like using, you could also use label replace on the name, on the name, because name under the hood is a label itself, a special label, but still a label, and doing something like a bit very unorthodox, probably, like, I don't know, label replace, old metric, name new metric, name old metric, something like that. And this probably, like, it really sounds far-fetched, but in any case, at least theoretically, the pros would be no need for write-time changes. Client storage can ingest whatever. No need for double write costs. But of course, as already hinted at, the cons, like for version read done this way as things stand now, as far as this OR solution or label replace solution is that the burden, the manual burden is high. It's impossible to assert for all consumers. And of course, it can be very inaccurate in some cases when there are transitions, when the two things are overlapping. So to recap, as you can see, no strategy nowadays at the current state is without significant drawbacks. However, the version read has enormous potential, we found out, but we need to make it automatic. So, is there a way to avoid those PromQL complexities and manual operations? In other words, can we do better? Can we devise a way to make rename seamless in Prometheus? What do you think, Bart?
Good question, Arianna. So we feel there is, and it's actually pretty accessible. So let's recap, how to implement a version read in Prometheus as it stands in an automatic way. So what we learned so far, right? When the metric is renamed in Prometheus, well, the moment the changes are deployed, your queries suddenly just stop working, hiddenly as well. So it's not only crashing, they're not crashing, it's actually, the results are not true anymore. So it's actually a much worse scenario to be in. So how we solve this? We first, have to establish some kind of schema, some kind of definition, something that captures the things that can change, right? Like metric name, like unit, label name, label values, if you have like maybe a set of known values, and even a type, right? And it could be as easy as a YAML file, something that can be clearly versioned and referenced for all of those different components. And this alone is extremely, extremely valuable for various things. You can generate documentation out of it. What metrics your organization or application has. You can validate schemas. You can, validate them, test them to see what is the impact of certain changes. But moreover, you can easily generate SDK code from the schema to different languages, right? So, for example, here we generated the schema into Go, Go code with Prometheus client Golang, which we maintain with Arianna. And this code is not only like automatically done for us, but it's more type safe. You can notice that labels are not strings anymore. You can kind of have a type of it. It's actually faster. There's potential to have it faster and have faster implementation of the instrumentation itself. And it's like just less room for mistakes. But for our naming problem, there is even bigger benefit. The moment, let's say, name changes, we can kind of capture that as another version, let's say 1.1. From this, we can really trivially generate a transformation or a changelog file that tells consumers how to upgrade and downgrade this metric, downgrade the shape of this metric, right? For the same semantic ID, let's say. Similar to any kind of schema migration you would see in Postgres or any other relational database. This transformation logic actually works pretty well for more complex transformations as well. So we can capture, upgrade, and downgrade for metric names. Units actually, if we have a value transformation, because the moment unit changes, you have to really map your samples to a different unit as well. Label name changes, label value changes. In future, we can potentially explore even changes like label splits and label merges. And this works for multiple changes layers on top of it very easily as well. So let's see how schema helps for our renaming scenario, right? When your metric will be schematized, and as you know, Prometheus generally were schemaless. Now you can have some of your metrics, important metrics, pointing to a certain schema. You'll be able to import auto-generated code for this metric in your code, which will assure the correct schema and also assure the correct reference to this schema. Then every series in every stage of the of generation, collection, storage, and consumption follows the schema and have its version reference, for example, as a Prometheus label. Now, with the schema information available for consumers, users could be able to maybe when they are making queries for important dashboards and alerts and tools, can pin a metric used in these queries to a certain schema and a version. And this way, the moment a new definition comes in, just on the YAML file, and imagine that nothing is, and it renamed, let's say, a metric, even if there is literally no deployment change, no code change, it's just kind of like the definition just upgraded, you will be able to kind of reference a new name, a new version of, and use new name of this metric immediately in your consumption, for example, in your dashboard, and it will work because Prometheus or any other backend will be able to fetch changelog transformation and do the conversion on the fly. And then when application starts to adopt this version slowly, it doesn't matter from the consumption side. This will still work as it is. And then even when a new version that never seen before and never consumption, never even captured, will be there, things will still work. So it allows essentially a huge flexibility on both producer and consumer side, and allows multiple cases. Okay, so how to do it in practice? How to have it in the next Prometheus release if you really want to? So we think there is practical answer, and we have to combine a following elements to implement this. So we need a schema definition, transformation, we need reference syntax, and schema engine implementation. Lots of work. Yeah, but turns out we have actually many of those things, fundamental things, already in existing CNCF ecosystem. So we need schema, right? But we don't need to actually redesign the schema, YAML, spec, and have the whole ecosystem for that, because OpenTelemetry exists, right? Of course, and we have a standardized schema spec for all the telemetry pieces, not only metric, actually. On top of schema itself, OpenTelemetry already defines hundreds of metrics that anybody can reuse, so the schema is already used, and they could be used in Prometheus ecosystem. In fact, OpenTelemetry has a rich tool set to perform operations on top of the schema. So the main tool is called Weaver. It's actually written in Rust, but it's very flexible, and it's already able to validate schemas, generate documentation, code transformation, and so on. And two maintainers, Lauren and Josh, had an amazing talk 2 days ago. So once it is on YouTube, please check it out. The tool is amazing, and we are using it in our prototype. So yes, you totally can define Prometheus metrics using Prometheus naming convention in OpenTelemetry schema. So of course, it's a little bit maybe sometimes awkward because in Prometheus we have labels, not attributes, and so on. We have metric types, not instrument. But there could be some overlay with more kind of like Prometheus-friendly names, but you could use it, and actually it's pretty pragmatic. One note is that I kind of tried to make it more pragmatic. So this YAML is kind of simplified version of OpenTelemetry schema, and we propose to add a special flag in in Weaver. Simple, so to make it kind of pragmatic for Prometheus users. Who knows, maybe they will accept that. But I think it is not super difficult to do that as a Prometheus user who may be used to defining metric in the hard-coded code, right? So it's not too bad. Thanks of that, well, we need to have transformations. So I was showing you a certain YAML format, but of course, OpenTelemetry already thought about this, and there is a transformation format. Unfortunately, it's limited. There are no limitations to this format. It was just not designed. It was designed for a first iteration, and OpenTelemetry knows about this, and there are different proposals to improve it. And we just came up with some new format that could be a new version, new format for OpenTelemetry. It could be something only for Prometheus. What we really try to do with this format particularly is to have it efficient for consumer use. So we made it specifically useful for backends to quickly look it up on the fly. So we really wanted to make it very efficient and pragmatic. So anyway, we come with this. I think it's pretty useful. We'll be discussing with OpenTelemetry community what could be the eventual version, but for prototypes, we could totally use this and auto-generate that from OpenTelemetry schema right now. We need reference syntax, so how we reference this schema, so how users could be able to pin their queries, and how storage will be able to capture the link between metric and the schema. This already exists as well, right? So OpenTelemetry have a schema URL, which is this notion of telling essentially where is your schema definitions and schema artifacts as well, generated artifacts. And you use it usually via some GitHub repos, and you can fetch it very quickly, and you reference it by some whatever URL and the version as well. So we can totally leverage that. We could put that as a label, and the moment query is having the special selector, which is like normal selector, but with schema URL special metric, it will actually do the magic. It will actually do the translation. Maybe one thing to note is that there are more efficient ways, so I will be proposing some maybe improvements to this. Ideally, it's not a schema URL, it's a schema ID, but those are nuances. I think a schema URL is good enough for a first iteration. And yeah, finally, we have to combine everything into something that uses all of it. And in fact, we already implemented that. It's kind of around 1,000 lines, and the schema engine itself. And it's as easy as adding one component in code between PromQL engine in Prometheus and storage layer that do the transformation in a transparent way. And here we go. So let's do the tricky stuff and do live demo. What do you think? Should we do it? Yes. So let me start to mirroring. Let's see how that goes. And let's do this. Oh, beautiful. So let me a little bit make it smaller. Yeah. Okay, so here we go. This is our query that broke, right? And why it broke? Because there is a new version of the same metric called, with a change name and then my number in class. So naive way that Arianna mentioned would be to add the or statement, right?
Yes.
And we said this is not ideal for various things. It's just complex. And of course, look what happened. It's actually a different series. And because not only because of metric name, but also because of label names that are totally conflicting. So it's not ideal. And also, you don't want manually to do this. So instead, you can tell Prometheus in this case that, hey, actually my metric has a schema, and it's actually old metric from 1.0 schema. And everything works, right? So it's on the fly, it's super fast. And you can totally use a new version at some point. You're like, actually, I like the new version, right? So let me use a new version. I have to actually bump the version of the schema, actually version 2. And then I have to rename my labels because, of course, it's a new version. And someone decided it would be a good idea to change. So why not? I can do that as well. So this is already, pretty flexible. And the main kind of like source of those possibilities is this kind of transformation file, which allows kind of Prometheus to go and find the exact spot of what's query desired to have and how to get there and how to kind of translate matchers I'm selecting through in storage and then how to translate something that comes from the storage back to desired version. So it's totally doable, it's totally fast. And I want to show you one more thing. So here's a histogram that actually changed a unit, which is not so trivial because it's not only metric name that changed, but actually, of course, a value, right? And of course, milliseconds. You can see the values are quite large because there are milliseconds. And then seconds, the new version is kind of, in seconds, so the value is smaller. So you can totally represent old metric as a new metric. So I want only seconds because that's recommended actually to have base units. And this will totally work. And you can confirm that by checking, where this metric comes from. It comes from the application who exposes 1.0 metrics. And we totally expose 1.0 metric as 1.2 dot metric and value change as well. So it just, translated on demand. So you can do amazing things with that. So back to our talk. If I can do it, yes. By the way, there is a full video on YouTube I already shared on LinkedIn. You can totally rewatch again for the demo. But let's go. I don't want to actually do this. How to switch? All right, do this. Yes. OK, bonus part. So there is this kind of funny, interesting thing happening in the ecosystem for like last 2 years. So Prometheus has its own metric convention, right? It has those suffixes, it has underscores. And OpenTelemetry at some point designed a different metric convention, naming convention, which is incompatible with Prometheus, right? They had their reasons, it's OK. They decided to use dots, which are not allowed, which used to be not allowed, and decided to not use suffixes, which, in our opinion, as a Prometheus maintainers, essentially removes many advantages of using PromQL in YAML files. Because when you look on the YAML file, you don't have a system that will tell you, oh, this is a seconds or this is a counter. So having that in name is actually actually crucial. But ecosystem wants to have this name, and that's OK. And this solution actually allows a single metric have two versions. And you can decide if OpenTelemetry users want to kind of have exactly the same OpenTelemetry metric. They can totally use a version that has this metric, and it will translate to this OpenTelemetry version of it. And then, if there is Prometheus fan and like a super strict person who loves this user experience of Prometheus naming, they can use that as well. So that's amazing because we can support both.
So we are almost at the end, and what are the learnings here? Where basically the learnings are that renaming metrics is actually very hard, and it's not trivial. Then you also having schema for your metric is actually a very cool thing. It has a lot of benefits. Weaver CLI from OpenTelemetry is absolutely amazing. And these schemas actually work for Prometheus too. And so, of course, there's some work to be done towards having more simplicity in this, having more efficient format transformation, etc., and to improve the schema URL, as Bartek said, with going towards like a schema ID. But we can work together towards these seamless renames in Prometheus and the ecosystem for a better world. And we're going to be at the Prometheus booth.
So that's it. Thank you very much, first of all. And we'll be here. I don't think we have time for questions, so we'll be here for a bit. And then Prometheus booth today and tomorrow.
Yes.
And please check the demo. Please check the pull request, review it, so we can have that feature. Please let us know if you'd like to put schema on your Prometheus metrics. And really, thank you so much.
Thank you for having us.